Isn't that? Yeah, that's a gay guy.
Hello. What?
Just Jack?
Oh. Hey, just Jack.
Old show.
We're on example 8. We got to do 8 and 9, I think. Those two little pieces. And then you have one homework assignment for 3-3. Okay, good?
Problem.
Okay, one more homework problem. Yes. Example 8. This didn't get put on here, so I'm going to... I need to photocopy this on here. This example is supposed to have a box and whisker plot for Verizon, a box and whisker plot for Sprint, a box and whisker plot for each one of these so that you can see and compare all of them. Okay, you don't necessarily have to write these down, but I will do that for you. Let's see what we got. Here we go. Verizon. I don't know why these all got taken off at one point. Okay, Verizon is at, there's my range. He starts just above 0. He goes here, and then he goes all the way to 80. Something like that. That's what Verizon looks like. Sprint is like here. That's what Sprint looks like, and he stops at like 25. That's his box and whisker plot. AT&T starts here, has a little box, and he goes to, I don't know, like there-ish. And T-Mobile, you don't have to write these down. We're going to compare them here in a second. His box is a little bit higher, and he goes to like there. Okay, there you go. Those are the box and whisker plots. And they compressed all this data. They did the 5-number summary. They did all the things for these 4 companies so that we can compare them. All right, so what are some things that we notice? Verizon's the longest, right? So its data speeds could be as low as 0 and as high as 80, right? So which one's going to have the most, like, variation? That one, right? Because its data is all spread apart. You're going to be the most PO'd at Verizon. True? People like consistency, even if consistency is bad, right? If you're used to your phone going dead in a certain spot, you're like, okay, I'm just used to that, right? Like, I can't call people there, right? Even if it's bad, you're just used to it being consistent. But if it's dropping calls in one spot and then, like, it's never done that before, but it's dropping a call now, like, the consistency, like, you like to have consistency. So if you're here one day and here the next day, you're going to be real pissed, right? Because you need to be consistent. What? Tell me about it. Yeah, exactly. I just switched from Verizon to U.S. Cellular, but they are now a part of T-Mobile. Best decision ever, because we have a U.S. Cellular tower outside of Lawrence. So, like, I was dropping calls inside of my house.
My parents are waiting until that new tower goes up.
Yeah, to switch. Yeah. So, even though Verizon is all over the spectrum, you're going to be real ticked off at them. Do we understand why? Right? People like consistency, even if, like, so Verizon, yes, you may have some days where you're at 80 and you're like, this is awesome, right? Sprint will never get up into the 80s, but people are probably more happy with this just because they're used to it, right? Okay? They're not going to be used to it if one day you're 0, one day you're 80. Like, they like consistency, even if consistency is bad. Good? So it helps us figure out, like, what's going on with some of these. Sprint, AT&T, T-Mobile look like they're probably okay. Which one out of those 3 is the least good? Sprint, right? Their little box is shoved to the left more so than AT&T and T-Mobile. Which one is the best out of those 3? What'd you say? I'm going to say T-Mobile. For the fact that, like, there's less variability. Their bar is like the shortest bar of everybody. And their data, their box is mostly to the side. Okay. Do we understand from what I was talking about the other day about there's the same number of data values in each one of those 4 sections, right? Okay. So it's not to say that like there's more numbers in this range when we do the box and whisker plot, right? It's just the majority of your data is condensed down to, like, all these numbers are close to each other, right? But they're the same number of data values in between each one of those four like sections, right? 4 quarters. Got it? Let's go to this guy right here, and there is an idiot-proof method for finding an outlier, okay? There's like a scientific method. So a lot of times we'll look at a data set and we'll say, I think that's an outlier. they have a method to actually find that. Okay, so I'm gonna show you that here in just a second. We have the Verizon airport data speeds that we had in like this section up top here, these guys, okay? And so we did the 5-number summary. So I'm just gonna erase and I'm gonna go back through that 5-number summary and we'll see how we got that information. We need what things for those 5 numbers? The min. Okay, so we start with the min, then go to the max, right? And then what do we find next? The median, the middle number, right? Okay, what's in between the min and the median? Right here. Q1, this is that first quartile. Some people call it P25 because that's the 25th percentile, right? Okay, and then the other one is Q3. Okay, so what we did, and you've already have this written down, the minimum was 0.8 because these are in order. The maximum was like 77.8. Okay, there are there's 50 numbers, right? Will we have an exact middle number? No. We'll have 25 numbers here, 25 numbers here. We will have to average which ones? The 25th and the 26th number. We'll have to average those together. 25th and 26th number was here and here. If we add those together and divide by 2, we end up getting like 13.9. Okay, then we use this range to find Q1. And there's 25 numbers there, so we will have an exact middle number. It'll be like the 13th number, and I think it was 7.9. Okay, and then we do the other 13th number, which is 21.5. That's my 5-number summary, right? Okay, I'm going to copy and paste that down to the bottom. If I can. Grab it, drag it. Come with me, come with me, come with me. Come with me. There we go. Look at that. How smart are we? All right, so here we go. We want to identify what our outliers are. So this box and whisker plot right here, if I map it out, we had like 0.8 here. We had like 77.8 here. We had like 21 was like here, 13 was here, 7.9 was here. Something of this nature, right? Okay. We get to decide what outliers exist, okay? And here's how we do it. We find what's called the interquartile range, okay? The IQR, write this down. IQR equals the length of the box. The IQR is the length of the box. It is Q3 minus Q1. So Q3 right here was that 21.5. Q1 right here was 7.9. What's the length of that box? What's that IQR value? What? 13.6. 13.6. Okay, now here's the deal. Here's how we decide what's considered to be an outlier or not. Okay, we take that 13.6 and we multiply it by 1.5. Okay, and then I'm going to add that to the 21.5. So 21.5 is the edge of my box, right? I want to go one more box length and then a half of a box length, right? I want to go 1.5 box lengths added onto the 21.5. So what's 13.6 times 1.5? 20.4. So I'm going to add 20.4 to 21.5. Yeah? If I add those two together, my cutoff mark right here is 41.9. Anything larger than 41.9 is considered to be an outlier. Okay, does that make sense? On the edge of your box, you're going to add another box and a half, and anything beyond that is going to be an outlier. Now, you do the same thing to find low outliers, but what happens if I add a box and a half over here? You're going to end up going into the negatives, so you're not going to have a lower end one, right? Okay, so anything larger than 41.9, let's go back up to our data here, right? 77.8 was an outlier. 71.3 is an outlier. 55.6 is an outlier. 43.0? Yes. 38.5? No, we have 4 outliers in that data set. You might think 38 and 43 are close together, so that's not an outlier. Those are outliers because my data, the rest of it is so like crunched together like on the low end. Does that make sense? So those 4 technically are outliers. Make sense? Yeah. So that is their scientific method of how they decide what's considered to be a really large number or a really small number, right? Okay, so use the Verizon Airport data speeds to construct a modified box plot. Okay, modified box plot. So now we're going to get rid of, we're going to subtract the last 4 numbers, right? Because those are my outliers. Okay, I'm gonna go back up to that box and we're gonna do the min, max, all that stuff again. Okay, I'll do it for you and then I'll drag it down. So if we get rid of those last 4 data values, holy moly, let's see what we got. We got a min, we got a max, we got a median, we got a Q1 and a Q3. All right, and let's see what this box and whisker plot looks like. So my minimum value is still going to be 0.8, right? Okay, but if I get rid of those outliers, what's the max value? 38.5. Okay, the median, all right, how many numbers do we have now? 46 numbers. If I split that in half, that's 23 here and 23 here. Do I have an exact middle number? No, I have to average the 23rd and 24th numbers, right? Okay, so I'm going to count from the beginning. This is 10, this is 20, 1, 2, 3, 23, and 24. What's the average of 13.1 and 13.5? 13.3. So he's right here in the middle, 13.3. Okay, now I have these numbers right here, and that's 23 numbers. We'll have an exact middle number again, right? Half of 23 would be 11, the 12th, like the 12th number, right? 12th number is 7.7. Okay, the 12th number, 18.2. This is what my modified box plot will look like. Come with me. That went faster that time. All right, so here's my modified box plot stuff. All right, so I'm going to show you what this looks like. Here's my ruler. We're going 0 to 80. We had a min of 0.8, max 77.8. Let me do my other markings in here. This is 40, this is 20, this is 60. Okay, I have 13.39 is my middle, 7.9, 21 point whatever. This is what my box plot looked like to begin with. You can go see that in like example 4. If I do my modified box plot, which is this guy, getting rid of those outliers, right? The min is 0.8. The max is 38.5. The median is 13.3, about the same as that one. 7.7, about the same. 18.2. Okay, this box plot looks a lot better than what the original one does. Just because I just got rid of 4 numbers. There's only 4 numbers that live from here on this way. Look at how spanned apart those are. Like, that is just as much distance as the other 44 numbers. There's 44 numbers that live from, 46 numbers that live from here to here. There's only 4 numbers that live from here to here. That makes sense? We got rid of those. We identified them as outliers, got rid of them, and now our box plot looks a little different, right? That's a modified box plot. Good? Okay, that is that. All right, so you have to do on this guy. They want you to find, listed below are the amounts of strontium in a sample obtained, blah, blah, blah. Are they in order? Yes, they are. They're in order. Perfect. Okay, so you have to just do your 5-number summary. That's all you have to do. You have your min, you have your and you have to make the box plot, right? Median, you don't have to identify any outliers or anything, is what I'm saying. So find those 5 things, okay? I don't know what you want to do on your chart if you want to go from...
I went to 180.
You went from 120 to 180? 120 to 180, that's 60, right? So, blah, blah, blah. Half of that would be like 150,
Yeah.
okay?
Take marks for
130, 140, 150, 160, 170, something like that, right? If you go that way. 130, 140, 150, 160, 170, okay? So find out those numbers there, like what your min, max, your 5-number summary, figure out what those guys are, and then make your box and whisker plot, okay? Good, good?
Can you?
Yeah.
Can you do Q1 and Q3?
'Kay.
And then on this
So how many numbers are there?
20.
20 numbers.
So is it
So
just like
what?
10 and 10?
10 and 10 over here, right? Okay. So will I have an exact middle number?
No.
No, right? So it will be there's the numbers, there's like the first through the 10th number over here, these the 11th through the 20th numbers over here, right? So my middle number will be in between the 10th and 11th
So you
number.
just
That makes
average
sense?
them?
You average them, yep.
Okay.
Yep, 10th and 11th number. 10th and 11th number, 2, 4, 6, 8, 10, 11. These two, right here. What's right in between those?
I think that's
Yeah.
the median, though, I thought.
That is the median. That is the median. Okay, so now I'm going to take this, I'm going to chunk this off. That's going to be where I find Q1.
Okay.
This is going to be where I find Q3. Yep.
Okay.
Okay?
And
Good,
that
good?
Should not be even.
And that should, no. You're going to have to average those also. Yeah.
Okay.
Yeah. Okay? All right? Do you guys have any other questions on the rest of this stuff besides that box and whisker play? On this homework assignment?
I think so.
I am going to be, oh my, I'm going to be gone tomorrow. I'm going to be gone Thursday. I'm going to be gone Friday. I'm going to be gone Monday.
Who's the sub?
Tomorrow's lines, then the other 3 days are Johnson, I think. Is from what I've heard. I don't know that for sure on Monday, but I'm pretty sure Thursday, Friday is Johnson.
Does she have
Tomorrow's
a
lines.
sensory date?
No, we have to go figure stuff out first. Yeah, they haven't even done, the only thing she's had is an MRI at this point. They have to go and do more imaging stuff.
Well, that's good that they caught it early.
I know.
So, what's going on?
Am I still recording? I'll stop.